Alright guys, I left you page 94, number 1 through 18 to look at yesterday for MCCR, and I'd like to go over some of the questions that I left for you, and then I have a quick tutorial for the next section that I'm going to have you be doing today. So there will be 2 videos, possibly 3, depending on how long some of this stuff takes. I'm going to pick out some of the questions that you guys had left assigned for you, and then if you have to fix up some of the ones that you still had questions about after we look at some of these, then you can go back and fix them. So I'm going to start with number 1 because that's a very particular type of problem. And all these things are revolving factoring. So when they're involving factoring, we're going to look at them as looking for a greatest common factor for all the terms. So I'm going to kind of separate the terms, factor them, and then we can figure out what is the greatest common factor for these things. So number 1 says 4x cubed plus 8x. And what you have to do when you look at that, first of all, is separate into 2 terms. That's a term, and that's a term, and they are separated by a plus sign. Since they're separated by the plus sign, that's what makes it. And if there was a minus sign, it would also be an indication that there's 2 terms. When I look at the numbers 4 and 8, I know that 4 goes into 8, but I'm going to be careful about how I write that. I also know, just from my experience, that x goes into x cubed. And since that's the case, I'm going to rewrite this a little bit before I do the actual factoring and pulling things out with the greatest common factor. I'm going to say, well, 4 is okay, but I'm going to write x cubed as x squared times x. Then I'm going to write 8 as 4 times 2. And the reason I wrote it as 4 times 2 is because 4, I've already determined, is going to be my greatest common factor. So there's a couple of ways to do that, and I'm going to choose to do it that way. Now that I've got that, I'm going to look at what I have in common and just kind of look at these 2 things. I see a 4 here in the first term and 4 here in the second term. That means it's a common factor. I see an x to the first power here and an x to the first power here. That means it's a common factor. So like yesterday, or 2 days ago, you were multiplying through and doing the distributive property. Factoring can be thought of as just undoing the distributive property, which is what it actually does. So I'm going to take that 4 and that x that I found in both of my terms and pull that out front, leaving me with inside here the stuff I didn't use. I got an x squared, and I got a 2 separated by that plus sign still. So that's what's going to be left in here. Now what I would look at is if I could get anything that goes into both of these things, x squared and 2, I would know that 4x would be a factor but not the greatest. Since no number goes into x squared, like it's something to have a coefficient out front, something that 2 would go into, and x squared can't go into a number like 2, I know that I'm finished with this problem now. The way you can check these in the most easy way possible, you should never have to get one of these wrong, because you could distribute just like you did on 2 days ago assignment and get back exactly what you started with. And if you did that, you would know 100% that you got it right. If you can factor it and then multiply back out to check on it, then that's how you could check your work no matter what it looks like. Now, number 1 is very similar to number 2, number 3. I'm going to take a look at number 4 because it's got some more exponents and variables and things like that, and that can be a little more confusing when you're looking at some of those things. So I'm going to go on to number 4, and the expression says a squared b to the 5th plus a cubed b to the 3rd. Kind of the way I look at this is I know that a squared goes into a cubed. I know that b to the 3rd power goes into b to the 5th power. So what I'm going to do is I'm going to write it, if I got an a squared here, I'm going to write this a cubed right here as a squared times a. A squared times a is going to give you a cubed, so I'm allowed to do that. B cubed is smaller, so I'm going to write that out here, but then I want a b cubed out of this first term. So I'm going to write b to the 3rd and b squared. What I've just written is just another form, a kind of expanded form of the first expression we started with on number 4. But what this allows me to do if I write it that way is to identify very quickly what the common factors are. I see an a squared in the first and the second term. I see a b cubed in the first and the second term. Doesn't matter where it is in the expression because we've got, those are separated by multiplication. So my common factor is going to be a squared b cubed. That's going to be pulled out front, and then I look at what's left. This and this are left, and they're separated by a plus sign. So I'm going to have my b squared plus a. And again, just like on the other one, you could distribute to check your work to make sure you did that right on number 4. Okay, pretty similar when you look at some of the other ones. It does get a little more, a little bit more complicated looking when you get to number 9. So I'm going to skip ahead to number 9 now. Hopefully you can do the ones in between there and see what you're left with. So we've got 6y squared. And then x plus 1 is in parentheses already. That's not going to hurt. X plus 1 is still representing a number. And if I see an x plus 1 there, and after this 8y, another x plus 1, just like on number 1, when I had a 4 that would go into 4 and 8, I've got an x plus 1 that's going to go into this first term and this second term. So I know x plus 1 is going to be a common factor, a part of my greatest common factor. When I look at 6 and 8 as numbers out front, I know that 2 is a factor of both 6 and 8. So when I think about how many times does 2 go into 6, I'm going to kind of think about it that way. I also know that y goes into y squared. So I'm going to separate this one just like I did the other ones because it's the same type of problem. Except for, since I know that 2 is a factor of 6 and 8, I'm going to write it this way. Instead of 6, 2 times 3. It means the same thing, so it's okay. Instead of y squared, I'm going to write y times y. There's my 6y squared. I've expanded it greatly. But I still have my x plus 1, which we said is going to be part of it too. 2 is the number that goes into 6 and 8, so I'm going to write this one as 2 times 4 times y, and times x plus 1. So let's look at what my common factors happen to be now, just like in the other one. I've got a 2 here and here. That means it's a common factor. I have a 3 here, but not in the second one, so I'm going to leave that alone. I've got a y here. Y to the first power here, y to the first power here, so that's going to be part of my common factor. I have another y in the first term, except I don't have another y to kind of pair with it. You're looking for pairs of things when you're looking for a common factor of 2 terms like this. And finally, I'm looking at this entire set of parentheses, x plus 1 and x plus 1, because it shows up in both terms. It's a common factor as well. What we can do then is figure out, I've got 2 and I've got y and I've got x plus 1 is my common factor. I'm going to pull that out front. Then, just like in number 1 and number 4, create a new set of parentheses. When I look at what's left then, in this first term, the only thing that I haven't pointed an arrow to are 3 and y, so that's going to be 3y. And the only thing I haven't pointed an arrow to here is 4. Again, that was a plus sign right there. If it was a minus sign, I would just do a minus here, but since that's the way it looks, that's going to be the most common factor, the easiest way to factor that particular problem on number 9. It's completely factored as far as we can do for our purposes here. Okay, you're going to see some things pretty close to that where you have a common expression in parentheses for the next few problems. The thing I notice about when you get to like number 13 is that you are looking at having 3 terms then. So I'll take a look at number 13 with you guys now and see what we can come up with as something that would actually work. But it's going to be very similar. Instead of looking for pairs of things, though, we're going to be looking for triplets of things. It's the best way to say it, I would guess. A squared b, 6ab cubed, and 15a to the 4th b squared. So you guys tried this one. I noticed right off the bat here 9, 6, and 15 are all multiples of 3. So I know that 3 is going to go into 9 and 6 and 15, and I'm going to use that idea. When I look at the letters for them, I got an a squared, an a to the first power in the second term, and a to the 4th. The common part of that is going to be the smallest exponent, so it's going to be a to the first power. And then when I look at the b's, I've got b to the first, b to the third, and b squared. So b to the first is going to be my common factor for that part. But I'm going to write everything with in multiples of 3, like 9 right here at the beginning is 3 times 3 times a times b. This one right here, instead of 6, I got 3 times 2 times a times b squared. Remember, I said right at the beginning that b to the first power is going to be my common factor, so I'm going to leave that b squared where it is, sitting right there. And then 15 is going to be 3 times 5, 3 being my common factor. A times a cubed, that gives me my a to the 4th, but separated. And b, oh, I put a plus sign and that's a no-no here, so let me erase that. That's supposed to be b times b. So when you look at these 3 terms right here, I'm going to underline them so they stick out a little bit better. terms are separated by plus or minus signs when you're talking about these polynomial things. I'm going to look at what's in common, and for each one of them I see right here a 3, a 3, and a 3. Since that's part of all 3, 3 is going to be part of my common factor out here. In each one of them I have an A, and an A. So A is going to be part of my greatest common factor. And then in each one of them I have a B, and a B. These are all B to the first power, just like they were A to the first power. So my greatest common factor is 3AB. What's left in each one of them, I've got 3 times A that I didn't match up with the other sides. So that's going to be my first term inside the parentheses. Here, I've got 2 and a B squared that weren't matched up. And finally here, I've got a 5, an A cubed, and a B. And those are going to be matched up like this. That's going to be my greatest common factor. When you look at it, the middle term inside the parentheses does not have an A, so I couldn't factor any more A's out. The first term doesn't have a B, so I couldn't factor any more. And 2, 3, and 5 are all prime numbers. Nothing goes into 2, 3, and 5 all at the same time. So that's why 13 would be done where it is right there. Pretty similar stuff. 13 was kind of a more difficult example for some of those things. And that's kind of where we'll leave you with that one. So this will be kind of some good examples to go by for your homework from yesterday. The next video is going to talk about factoring trinomials and kind of the methods that we might want to use with those to make that a little bit easier. So after you've checked some of your work there, your teacher's going to start that next video in a couple of minutes, and you can figure out what we can get done with those type of things. So hopefully this helped. Again, if you need to look back at it, my YouTube channel is Craig Reinhardt Gmail. There's no spaces, no uppercase or anything like that. You can find this video, and this video is going to be titled MCCR Page 94, number 1 through 18. It's really incredibly inventive the way I come up with the titles for these things. So that's where you can find it. Hopefully everything goes well with you guys, and have a good night.